Hello everyone, welcome to MBA Karo. So today is day 29 of this hot summer series and last two videos left for this series, and in this video we are going to do some miscellaneous topics on LR. One is team selection, another is cubes, and another is binary logic. So we will see a couple of sets from each of these. So please do watch these videos to understand these topics and examples of the same. If you are new to the channel, please don't forget to subscribe to the channel and follow us on social media platforms. This is the schedule and we are on day 29. Please watch this entire series, and I can assure you that if you watch all these 30 videos, you will benefit a lot for your CAT preparation, and do recommend the series to others as well who are preparing for CAT and other MBA entrance examinations. We have a batch running for CAT 2024, so in case you wish to get discount on it, you can use the code HOT to get 20% off. In this you will get top notch content. You must have already judged our content like through these classes, so the quality of content that we have, the teaching methodology we have. Okay, if you wish to prepare for CAT in a structured manner, you can enroll in our CAT batch. So please try to solve the sets and then look at the solution. So let's begin with the first set, which is on selection. So it says that there are 6 tourists, you can call them A to F. They are assigned to 4 guides G, H, I, J. Each tourist is assigned to exactly one guide, with at least one tourist assigned to each guide. So each guide will have at least one tourist, and all tourists will have only one guide. Each tourist speaks exactly one of the languages spoken by his or her guide and speaks no other language. So there has to be a match between the language spoken by the tourists and the guides. So it says Ganesh speaks only French. So Ganesh speaks French. Harsh speaks Turkish and Spanish. Indu speaks French and Turkish. And Jaspreet speaks Spanish and Russian. Okay, so these are the languages known by the guides. So accordingly they will be assigned tourists. It says at least Andrew and Beth are assigned to Indu. So that means A and B are assigned here. At least Daisy is assigned to Jaspreet. So Daisy is assigned here. If Charles is assigned to Harsh, then Evans speaks French. So the condition of if is, if Charles is assigned to Harsh, then Evans will speak French. So suppose Charles is here, then Evans will speak French. But if Charles is not assigned, then Evans can speak French or he may not speak French. So if condition is satisfied only when the if part is true. So if this is true, if Charles is assigned to Harsh, then this is true. If this part is false, then we can't say that what language Evans speaks. Okay, so this is the condition that is given to us. Now we will use these conditions and the questions based on these. So the first question says, which of the following must be true? Harsh is assigned fewer than 2 of the 2 tourists. So it says Harsh is assigned less than 2 tourists, right? Is it true? So it is saying must be true. It should be compulsorily true. So it says fewer than 2 tourists. So if we assign 2 tourists here, right, is it possible? So there are 6 tourists. We can assign 2 tourists to Harsh. Okay, so we have A, B, D is done. C, F, E are pending. Okay, so we can assign C and F here and E here, which is quite much possible. So we can assign 2 tourists to Harsh. So this is not true. Indu is assigned exactly 2 of the tourists. So Indu is assigned 2 tourists. What if we assign 3 tourists to Indu and 1 more person to Indu? Is it possible? So we can assign C, E, F. It is not ruining any of the conditions, so it is also possible. Okay, so this can be proven wrong. Ganesh is assigned exactly one of the tourists. Now instead of assigning 1 tourist, we can assign 2 tourists here. Quite much possible, right? So we can assign C, E, F like anything, because no constraint on these things. So this is also false. So if 3 statements are false, then obviously the 4th option has to be true. Let's see whether the 4th option is true or not. Jaspreet is assigned fewer than 3 of the tourists. Now in order to prove it false, if we assign 2 more people here, so it will become 3 people here, 2 people here. So we have to assign 2 more people. So it makes the count 7 and there are only 6 tourists. So this is true. Okay, easy one, that only fourth statement can be true. Now the thing is, you need to be particular with the words. Now most students would answer A because they would say that Harsh is assigned fewer than 2 of the tourists. So people will assign 1 and say that yes, that is true. The question is saying which of the following must be true. Must be true means true in every sense. So we need to try to prove other statements false. As long as we can prove other statement false, that means that statement is not necessarily true. So that's our task in hand. Let's move on to the next question. It says, if Daisy and Fiona speak the same language as each other, what is the maximum number of tourists who could speak Turkish? So we'll make the table again. So G H I J. So it says that he speaks French and Turkish and Spanish, and French and Turkish, and this person Spanish and Russian, and we assigned A and B here and D here. Okay, now it says Daisy and Fiona speak the same language. So Daisy and Fiona speak the same language. So what language can it be? So Daisy, see, Fiona we do not know the language. Daisy can speak Spanish or Russian. Okay, now if Daisy speaks Spanish, so we'll make two cases. One is Spanish, one is Russian. So if Daisy and Fiona speak like same language as each other, what is the maximum number of tourists who could speak Turkish? So we need to find maximum tourists who can speak Turkish. Okay, so we have to make Fiona and we have to put 3 people here. Okay, so Spanish, let's take Spanish. So we can make Fiona Spanish here. Okay, so if we put F here, we have one more person. So whoever that person is, we are not at all concerned. So we have to make 6 people. So let's make the 6th person here. Okay, so we need to find the maximum number of tourists who can speak Turkish. So we can have this person and this person speak Turkish. So we can have 3 people speaking Turkish. Now you might be wondering that why can't Fiona speak Turkish? We are assuming that Fiona is speaking Spanish. Now let's take another same, like can we maximize this number further? Okay, so let's not put answer 3, let's see that if we can further maximize it. So suppose both of them speak Russian, right? So Daisy and Fiona speak Russian. Okay, so we have put here, now A and B were here, and we need to put one person here. So we cannot take more than 2 in this case. But if you take Fiona here, we can have 3 people speaking Turkish. So this gives us only 2, this gives us 3. So we will choose the higher number. So we can have maximum 3 people speaking Turkish. Here's the next question. It says, if exactly 2 tourists are assigned to Harsh, then which of the following could be true? Could be true means that it can be true, it can be false. So that means all other statements have to be false. Okay, so now again we will do the same thing, GHIJ, and the languages are French, Turkish and Spanish, French and Turkish, and we have Spanish and Russian. So A and B were assigned here and D were assigned here. Now the condition is given that 2 tourists are assigned to Harsh. So 2 tourists are assigned here, 1 tourist will be assigned this side. Now we need to tell which of the following could be true. So all others should be false. So first says Ivan speaks French and Charles speaks Spanish, right? So Ivan speaks French and Charles speaks Spanish, quite possible, right? So we are given that if Charles is assigned to Harsh, okay, that means Ivan speaks French. So that is possible. So this becomes our answer. Let us check if others are false. Like some people get doubt that how could option A be correct. So we want to check the others. Let's check. Fiona speaks French and Ivan speak French. Okay. So if you have to make Fiona and Ivan speak French, so we need, like, see, these 3 places are remaining. So in order to make French, we will have to put these 2 here, or 1 person here and here. We cannot assign 2 people here. Okay, so if you make one person here, one person here, so this makes already 5 people. We cannot have 2 people in this category. Or if you put both people here, we cannot have 2 people here. So this is false. Fiona speaks French and Charles speak Turkish. So if you like put Charles as Turkish, then Charles is assigned to Harsh. Ivan speaks French. So Ivan also speak French. Fiona will also speak French. So that is not possible. Okay. And then Ivan speaks Spanish and Charles speaks Spanish. So Ivan and Charles, if they speak Spanish, so they will be assigned here. But the condition says that if Charles is assigned to Harsh, Ivan speaks French. So this is not possible. And if you like Ivan speaks Spanish and Charles speaks Spanish, so if you assign Charles here, we cannot assign 2 people to this person. So that means only the first statement could be true. Rest are definitely false ones. Next one, if Andrew, Beth, Ivan and Fiona all speak the same language as each other, which of the following could be true? Okay, so could be true means all rest will be false. So GHIJ, let's put the languages. Andrew, Beth, Ivan and Fiona all speak the same language. Now that same language can be French or it can be Turkish. So we'll make 2 cases, that all speak French and all speak Turkish. Okay. Now if all of them speak French, so we have to assign 3 more people. So at least 1 person should be assigned here and at least 1 person should be assigned here. Okay. So we have 1, 2, 3, like 1 person has to be assigned, like the 6th person can be this one or this one. Okay. So this, like this is the arrangement, like either 2, 2, 1, 2, 1, or we can have this is 1 person, 3 and 1. So they can speak French. Now if they speak Turkish, then in that case A, B, this is D. So Turkish means we can assign 2 people here. So 4 people speaking Turkish and the 6th person here, or we can assign 3 people here and like this, like 1 person here, 3 persons here and 1 person here. Okay, so that are the different arrangements possible, not to put the names here. Okay, and then let's look at the conditions. So it says that Charles speaks Russian. Okay, so in no case we see Charles is in this category because this will have only 1 person. So this is false. Exactly 2 of the tourists speak Turkish. Okay, now if we make 4 people Russian, right? So French, they either speak French or they speak Turkish. So if we make 4 people Turkish, then it is wrong. If you make 4 people Turkish, it is obviously wrong. We have to make 2 people speak Turkish. So if 4 of them speak French, so we have 1, 2, 3 French. So this is French, French and French. Then 4 people are speaking French. So that means 2 Turkish, but that is not possible because D is speaking either Spanish or Russian. Okay, so we cannot have 2 Turkish. So this is wrong. And if you take 4 Turkish, then obviously it becomes wrong. Charles speaks French. Okay, so can we assign Charles here? See, if Charles is assigned to Harsh, then Ivan speaks French. If Charles is not assigned to Harsh, Ivan can be assigned anywhere. So we can assign Charles here. Possible. In this case also we can assign Charles here. So possible, right? So could be true means this could be true. Let's evaluate the last option and see that if that also could be true. Exactly 2 of the tourists speak Russian. Okay, see, only this person speaks Russian and we have to have 2 people speaking Russian. So we cannot assign 2 people here. So all the other statements are false except the third one, which could be true. It says could be true. So you need to understand the difference between could be true and must be true. Could be true means that there is a chance it can be true, and must be true means that it is always true. Okay, so that was one of the sets. Now let's see the next one. It says that the chief minister of a state had to select 5 ministers in his cabinet out of these people. Okay, now this is quite an interesting one, so try to solve it on your own. and then look at the solution. So the ages are 36, 38, 39, 45, 48, then we have 54, 57 and 59. Okay, so these are the ages of these people, right? Then we are given that we have to select 5 ministers, and these are the ages of these ministers. From these 8 ministers, the CM to select at least one minister in his 30s, at least one minister in his 40s, and at least 2 ministers in their 50s. So 30s में हमें minimum 1 चाहिए, 40s में minimum 1 चाहिए, and 50s में minimum 2 चाहिए. Okay, so that is at least 4 have to be of these type, and then the 5th one could be anything, right? So for 4 of them we are assured that that has to be the selection, right? Now it says that now if and selection conditions are given. If Lakshman is in the cabinet, Mukesh must not be in the cabinet. Okay, so let us first try to find out the ages of these people, so that we can probably find we can find who is in the cabinet. So Suraj is in his 50s, will be in the cabinet only if Mukesh is in the cabinet. So Suraj is in 50s. Okay, so let's write these names and see that what could be the possible ages. So J, K, L, M, R, S, T, U. Okay, so we need to find that what could be the possible ages. So Suraj is in 50s, so Suraj could be 54 or 57 or 59, right? Possible ages. Raj is 6 years older than Lakshman. Okay, Raj is 6 years older than Lakshman, so Raj, Lakshman also we will take the possibilities. 6 years difference is 39, 45. Okay, then we have 54 and 48. So these are the 2 possible cases of Raj and Lakshman. So we will have to make first age based scenarios. Then Kunal is in his 30s, so Kunal can be in 36, 38 or 39. Suraj is younger than Uday, so Suraj is younger than Uday. So if Suraj is 54, then Uday can be 57 or 59. Okay, and if Suraj is 57, then Uday can be 59. So Suraj cannot be 59. So these are possibilities of Suraj and Uday. So in this case, Uday can be 59 also. So these are the possible ages of Suraj and Uday. Okay, then Tarak is 3 years younger than Jatin. Okay, so Tarak and Jatin, we will find the possibilities. Tarak is 3 years younger, so we can have 36 and 39. Then we can have 45 and 48, and then we can have 54 and 57. Okay, now we can probably eliminate this case 54 and we can eliminate 54, 57, because if you take 54, 57, right? So if you take 54 and 57, no possible age remains for Suraj, so this is not possible. Okay, and then we have Raj is 6 years older than Lakshman, so that is a possible age. So we will basically have to figure out some more we will have to make some combinations to include all these people. So Kunal has to be in the 30s. So if we take this 36 and 39 wala case, so let's make some cases to figure out the ages of people. Okay, so we are taking this case 36 and 39 because we know that this will give us only one case. So if we take Tarak as 36, okay, Tarak as 36, Jatin will be 39, then Kunal will be 38. Okay, Kunal is 38, so this 39, 45 is not possible. Okay, so then we will have 39 and 45 is not possible because 39 is already taken. Okay, so we will have L as 48 and R as 54. Okay, if R is 54, Suraj has to be 57 and this has to be 59. So remaining age is like 36 has been used, 38 has been used, 39 has been used, 45 remains. So M can be 45. Okay, so that is one possibility, isn't it? So that is one of the possibilities. So we are taking this green case, this blue case. Okay, so let's make another possibility. Let's say if we do not take this case, if we consider 45 and 48. So we started with this case. Why did we take this case? Because that gave us a clear number for Kunal. So if we take 45 and 48, so if we take Jatin as 48 and Tarak as 45, then what will happen? We cannot take this 45 and 48 because there are only two cases left for Raj and Lakshman. Okay, so there is 45, 48, so 45 is also used, 48 is also used. So we cannot make the case. So fortunately we are able to find the ages of all these people. So we have like 36 years old is T, and then we have K, J, okay, then we have M and L, then 54 is R, S and U. So these are the ages of these people, right? So at least age based questions can be answered using this data. So there is one question, what is Mukesh's age? So Mukesh's age is 45. Okay, so now we will have to find how many ways can we select the cabinet. Now we will use the conditions of making the cabinet. So it says that if Lakshman is in the cabinet, Mukesh must not be in the cabinet. So they cannot be together. Suraj will be in the cabinet only if Mukesh is in the cabinet. Fine. So if we include Mukesh, we will have to include Suraj also. Raj and like Lakshman, if one of them is in the cabinet, the other must be in the cabinet. So let us make one case that Raj and Lakshman both are present in the cabinet, and another case that both of them are not present in the cabinet. So if both of them are not present, that will lead us to 6 people out of 8. Okay, and one of them, let's make Raj and Lakshman both, because if we see the conditions, there is some link between Raj and Uday. Okay, there is some link between Lakshman and Mukesh. Okay, so let's make these two cases. So let's say if Raj and Lakshman both are in the cabinet, so Raj is there, Lakshman is there. Okay, if Lakshman is in the cabinet, Mukesh must not be in the cabinet. So Mukesh cannot be in the cabinet in that case. Okay, if Raj is in the cabinet, Uday must be in the cabinet. So Raj is there, Uday is also there. Okay, so age based we have done. So it says Kunal will be in the cabinet only if Uday is not in the cabinet. Okay, fourth point, it says Kunal is in the cabinet only if Uday is not in the cabinet. So Uday is present in the cabinet, so Kunal cannot be present in the cabinet. Okay, now Lakshman is in the cabinet, Mukesh must not be in the cabinet. Then we have T and J, so we have to select 2 people out of them, and Suraj will be in the cabinet only if Mukesh is in the cabinet. So Mukesh is not present, so Suraj cannot be present in the cabinet. So this is the cabinet in this scenario. So we will get only one unique case that these 5 are present in the cabinet. Okay, now next case is we do not take, so we have considered this case, we get a unique cabinet selection. Now we will take the case where both of them are not present in the cabinet. So because we have removed 2 people, we have to select 6 people. So it should be easy to select. Now one of the persons in 40s should be there, one of the persons in 30s should be there, 2 of the people in 50s should be there. So these 2 people get automatically selected. In 50s, this person also gets selected. So we need to select 2 more people out of them. Okay, now Lakshman is in the cabinet, Mukesh, so Lakshman is not there in the cabinet, so this case is taken care of. Suraj will be in the cabinet only if Mukesh is in the cabinet. Okay, So Suraj will be there, that means Mukesh, so that is already satisfied. Raj, the other must be in the cabinet, Raj and Lakshman, so that is also we have taken care of. Kunal will be in the cabinet only if Uday is not in the cabinet. So Uday is present in the cabinet, so Kunal will not be in the cabinet. So Kunal is not present in the cabinet, so that means we will get these two people present in the cabinet. Okay, so I think it satisfies all the conditions. Suraj is Uday will be in the cabinet, Jatin is in the cabinet, so Jatin is present, Uday is present, and Raj is in the cabinet, so Raj is not in the cabinet, so this case is taken care of. So we get two ways of selecting the cabinet. So in how many ways? It can be selected in two ways. What is Mukesh's age? Done. Who among the following can never be in the cabinet? So if you see, in both cases we cannot have Kunal in the cabinet. If the second oldest person is in the cabinet, who among them cannot be in the cabinet? So second oldest person, that is, we will consider this scenario, right? So Suraj is in the cabinet, so we have LRK. So Raj is not in the cabinet. So this scenario, he is present, Raj is not present. Okay, so we get this answer to this particular set. So I hope you enjoyed solving this set. So please don't forget to like this video. It was an interesting set. Now let's do the next variety of questions, which is called binary logic or truth lie based questions. Okay, so read this set and try to solve the questions on your own. If you are unable to solve the questions, then look at the solutions. Okay, so I'll begin with the solution of the set directly. You read the question, try to solve it, and then look at the answers. So it says each of the 6 friends, they are 6 friends, they took one ball from a box. It had 30 balls of 6 different colors. So there are ample number of balls. Okay, the number of balls of each color is the same, so 5 balls of each type. Okay, they took one ball from it. Okay, now some detail is given about the 3 statements made by each of the persons, and we are given that exactly one of the statements by each person is true and only one of the statements made about Lalit is correct. Okay, so for every person we have 1 true and 2 false statements. Okay, also balls of 2 particulars were not particular colors were not taken by any of the people. So one person has picked only 1 ball. Okay, now what we do in these cases is we try to find some contradictory statement. Okay, so if you see this, Lalit took a blue ball, Lalit took the same colored ball as Edwin. So we cannot say that this is a contradictory statement. Rizwan did not take a yellow ball, Sukhbir took a black ball, so no contradiction. Edwin took a white ball, Rizwan did, so we do not see any contradiction in first 4 people. Okay, then it says Tony took a yellow ball, Ankit took a yellow ball. Now some people might think that it's a contradictory statement. Contradictory means they have to be opposite. Now 2 people can pick the same color ball, right? Because 5 balls of each color are present. So it is not contradictory. Now if you start with Sukhbir, Sukhbir says Tony did not take a white ball, Tony took a white ball. Now this is contradictory because it is just opposite of each other, right? If I say Tony took a red ball and I say Tony took a blue ball, that is not contradictory. Okay, I mean there would be contradictory because only 1 ball is chosen. But if I say like this, these 2 are not contradictory because 2 people can take same ball, same color balls. Okay, so this particular statement is contradictory. Now when you have contradictory statements, one statement is false, another statement is true. So one of them has to be false, another one has to be true. So we figure out 1 true statement, 1 false statement. The third statement has to be false. So this is false. If this is false, then Edwin did not take a blue ball. So Edwin took a blue ball. So Edwin has taken blue ball. Now what we will do? We will look for statements that talk about Edwin's ball and find out whether the statement is true or false. Okay. Now it says that Edwin took a white ball. This is false. Okay. Edwin took a green ball. That is also false. Right. So we have figured out some false statements. Now if you look at this statement, it says that Lalit took the same colored ball as Edwin. So basically it says that Lalit took blue ball. Okay, that's what it says. And it says Lalit took a blue ball, right? Now what happens if two people say the same thing? Like this is the same statement. Lalit took a blue ball, because we know that Edwin has taken a blue ball, right? So it says Lalit took a blue ball, and it also says Lalit took a blue ball. So only one can be true, right? So if only one statement can be true, both of them cannot be true. So both of them can be false. So it means that Lalit did not take a blue ball. So he is not taking a blue ball. So Tony took a red ball. That is correct. So Tony is red. Now all statements about Tony's ball color, we could use it, right? So it says Tony took a yellow ball. That is false. Okay. And then it says that so this is false, and Tony took a white ball is false, and Tony did not take a white ball. This is true, right? So Tony took a red ball. That is known to us. Okay. Now we have now one more thing, because we have figured out these statements, right? These statements based on the ball color. Now one more thing that is given to us, we cannot find any contradictory statement after this, like Sukhbir, Rizwan, different people, different statements about different people. Ankit, Sukhbir, Lalit, statements about different people. We will use this condition. Only one of the statements made about Lalit is correct. So we will find the statements about Lalit. So Lalit mentioned here, false. Lalit mentioned here, false. Okay. Then we have Lalit, one of the statements is here, and that is the only statement left about Lalit. Okay. So that means this statement should be correct. So Lalit took a green ball. Okay, so Lalit is green. Okay, if this statement is false, so these two have to be wrong. Okay, so Sukhbir did not take a red ball, so that means Sukhbir took a red ball, right? And Ankit took a blue ball, so Ankit cannot take a blue ball. So we have determined these statements. So we have determined the statements for Ankit. We have determined the statements for Edwin. For Sukhbir we have determined. We are left with these three people, right? Rizwan says I took a green ball, Ankit took a yellow ball. Different people. Lalit says Rizwan did not take a yellow ball, Edwin took a green ball, Sukhbir took a black ball. Now if you see this, Sukhbir took a red ball, so this is incorrect. So this statement has to be correct. So Rizwan did not take a yellow ball, so Rizwan is not yellow. Okay. Then we have like Tony says Edwin took a white ball, Sukhbir took a black ball. So his statement is also false, because Sukhbir is taking a red ball. So this has to be correct. So Rizwan did not take a red ball, so he cannot take a red also. Now last person that is left is Rizwan. I took a green ball. He may take a green ball. Ankit took a yellow ball. Ankit, we are not given blue, so Ankit can have a yellow ball. So we can't tell which of these statements is correct, but we can tell about the remaining, like out of these remaining statements we can tell which ones are correct, which ones are not correct. So basically for Rizwan we cannot determine the statements, and we can find the colors for 4 people, and we can say that for the remaining 2 which are the colors that they cannot take. So what is the color of the ball taken by Sukhbir? So Sukhbir has taken the red ball. For how many mentioned persons the exact color of the balls taken by them can be determined? So we can determine for 4 people. Which 2 friends surely took balls of the same color? So we have 2 people, Sukhbir and Tony. So they have taken the red ball. So both of them have taken red ball. What is the color of the ball taken by Edwin? So for Edwin, we know that the ball is blue color. So this is how we solve these sets which are based on binary logic. So we start with some contradictory statements. Okay, so here's the next one. Read these conditions, and once you have read, so then move on to the next one. Okay, so it says that like there are 4 districts in the state of Ossia named Aldova, Beverny, Comet, Dolby. There are 4 types of individuals in the state as follows. So positive is they always speak the truth, so they will speak truth. Negative, they speak lie, so they will always tell lie. Semi-positive speak truth and lie alternately. The first statement is truth, second is a lie, third statement is true, so they will speak like this. Okay, they will continue to speak truth, lie, they speak like this. And semi-negative speak the lie and speak the truth alternately, so it will be lie, true, lie, true, lie, true, and so on. So that is semi-negative. Okay, now it says that there are 4 people, P, Q, R, S, and there are 4 residents, and exactly one of them falls under each of the categories: positive, negative, semi-positive, and semi-negative. So 4 people falling in 4 different categories. It is also known that each one of them is from a different district. Okay, so they are from a different district. The following statements were recorded for these individuals, and okay, so repeat. So Pushkar says that Rahman is negative, I am from Comet, the person from Delve is positive. So if you are solving this set, which I suppose before looking at the solution, please try to make the table and then look at the solution at the next slide. Okay, so please try to make the table that who is from which tribe, who is speaking truth, and who belongs to which category. Okay, and now I am going to solve the set here. So we are given that these are 4 people. Okay, P, R, S, right. So we will make the statements, whether the statement is true, false, or true. Okay, so we will make true. For true we will mark tick, and false we will mark cross, and then we will find the place they are from. Okay, so they are of different tribes and the place. So tribes we will get by like true and false. We will have to find the place. Okay, so Pushkar says Rahman is negative, I am from Comet, the person from Dulve is positive. We can't trust anyone, like based on the statements. So we need to know certain things. The only thing we know is all people are from different place and are of different tribes. Okay, the other thing we know is 2 of them will speak truth, 2 of them will like one of them will speak truth, one of them will be in lie, and there are 2 alternatives. So Quinton says the first statement spoken by only one of us is a truth. Okay, now see what is the pattern of these people. So one person is all true, one person is all false, one person is true, false, true, another person is false, true, false. Okay, now it says the first statement spoken by only one of us is a truth. We see that the first statement by 2 people is going to be the truth. Okay, so that means this statement is false. So Quinton's first statement is false. Okay, so Quinton can be of this category or this category, we cannot tell. So if Quinton's first statement is false, the third statement should also be false. See, if the first is false, third is also false. So first or third false ho jayenge. Second statement we will evaluate later. So it says that the person from Aldova is negative. So Aldova is not negative. Not negative. Okay, so we'll put it for now. Then it says Rahman says the first statement spoken by 2 of us is the truth. So we know that the first statement is true for 2 people, so this statement is true. So Rahman's first statement is true, and if his first statement is true, third will automatically be true. So the person from Beverny is semi-positive. So Beverny, the person is semi-positive. Okay, semi-positive. Aldova is not negative, that we have known these statements. Okay, Then I am from Moldova, we cannot say that the person is from Moldova or not. Okay. Then it says that Sukhbir says the first statement spoken by me is a truth. Can be, cannot be, right? Because we may have a person speaking truth or not. I am from Dalvle, can't say. Okay, the person from Comet is a semi-negative, can't say, because B is semi-positive. We cannot say that D is a semi-negative. So let us evaluate Pushkar's statement. Pushkar says Rahman is a negative. Now Rahman, the first statement is true. So R can be this or this. So Rahman cannot be a negative. So negative means all three are false. So Pushkar's first statement is false. So if his first statement is false, then last statement has to be false. Similarly, for Sukhbir, the first and third statements have to be true. So this is a very valuable thing. If the first statement is true, third has to be true. Okay. So Rahman is not negative. The person from Dalve is positive. So Dalve is not positive. Okay. So that we again get. Now Sukhbir says the first statement spoken by me is a truth. We already know this. Not needed. The person from Comet is a semi-negative. Okay. So from C it is the person is semi-negative. So we know that the person from like B is, so now we can get one thing like A, B, C, D, the places. So Comet is semi-negative, B is semi-positive, and this is not negative. So Moldova will be positive and this will be negative. Okay, so that's what we can get, that these are the 4 people from 4 of the tribes. Now the thing that is remaining is the central statement of all 4 people. So let us evaluate the central statement of all the people and see what do we get. So Pushkar says I am from Comet. Okay. So Comet is semi-negative, semi-negative possible. Okay, possible. We will put it on hold. So let's leave the second one. Quinton says I am from Beverny. Okay. See, Beverny is semi-positive. Who is semi-positive? Semi-positive is the one who speaks truth, lie, truth, lie. Now it says that I am from Beverny. See, Quinton cannot be semi-positive, because we know that the semi-positive first statement has to be true. So this is false. So we know that Quinton, all 3 are false. So Quinton belongs to the negative category and is from D. Okay. Now we have evaluated this. Rahman says so this will be semi-negative. Okay, so this is negative and this will be semi-negative. So semi-negative is from place C. Okay, so this is negative and this is semi-negative. So we are left with semi-positive and positive. Then now Rahman says that so he is from Comet, that also becomes true, validated. Next is Rahman who says I am from Moldova. Moldova is positive, may be true, right? We can't say that it is true or false, because may be true, may not be true. Sukhbir says I am from Dulve. So Dulve we already know, Quinton is from Dulve, so his statement is false, his statement is true. So this is negative, this is positive, and this is semi-positive. Okay, so semi-positive is from B and this person is from A. So this is how we solve the conditions and find out who belongs to which tribe, which statement is true or false. So how do we solve these binary logic based questions? Is either contradictory statements or from the information that we already know. In the previous set also, the ball picking, we knew some of the statements and then figured out whether the statement is true or false. In this case, we knew that the first statement for 2 people, like these statements, helped us to start, because we knew that the first statement by 2 people are true and by 2 people are false. Who is from Delve? So Delve is Quinton. Who among the following are neither positive nor negative? So basically we have to find semi-negative and semi-positive. So P and S. Which of the following statements is correct? Beverny is positive, no. Comet is semi-negative. Comet is semi-negative, so this is correct. Okay, and Comet is semi-negative, right? Yeah, so that is right. Which of the following combinations is correct? Pushkar Aldova positive, Quinton Comet negative, then we have Rahman Delve semi negative, and Sukhbir Beverny semi positive. That is the correct combination. Okay, so this is the solution to the set based on binary logic. Okay, so I hope you are enjoying this session and learning something new, especially if you did not know how to solve binary logic based questions. Now you know how to solve these questions also. Now let us move to the next category, that is cube based questions. Okay, now there are certain simple cube based questions, like if a cube is cut into so many parts, how many have one side painted, two side painted, etc. We are going to do some good visualization based problems. So try to solve the question set, and then I will discuss the set. It says that we have a cuboid. We do not have a cube, we have a cuboid instead. And in this we have basically it is broken into 120 pieces, 120 equal pieces, by making the least possible number of cuts. So least possible number of cuts means we can have 6 into 5 into 4. Okay, so that is the dimension of the cubes. Okay, a cuboid. So this is cut into 120 pieces. Now it says that they are painted by 3 different colors: red, blue and green. Okay, red, blue and green are the colors of these pieces. So what is the least? Now it is saying that 3, such that each color is painted on at least one face. So we can have, like, see, it is not necessary that each face will have, 2 faces will have one color each. So we can have one side painted red, one blue. So let's see the different possibilities that we may have. So we may have 1 1 4. Okay, we may have 3 1 2 3 2 1. Anything is possible. We can have 2 2 2 also. So no such guarantee that how many sides are painted by which color. Okay, but at least one side has to be painted by like one of the colors. Now it says, what is the least and the highest possible number of small pieces with 3 colors painted on them? Okay, so 3 colors will be painted when we have 3 different colors. Okay, now let us make one case that we paint red here and we paint blue here, and rest all we paint yellow. Okay, so if we paint all other yellow, so you see that we cannot have all 3 colors at this junction. We cannot have all these 3 colors at this junction, because this is yellow and like this is red and this is yellow. Okay, so we have 2 yellow and blue, like we cannot have all 3. Similarly, we cannot have all 3 because red and blue are separate. Okay, so we can have 0 as the least number, is 0. Now we need to find the maximum number of cubes that are in all 3 colors painted. So suppose we paint the opposite colors red. Okay, we paint these 2 as blue, the top one and the bottom one, and these as yellow. Now this is R B Y, this is R B, and we have red on the opposite side. This is B and Y. So this is R and Y, blue on the bottom, R and Y, blue on the bottom, R and blue on the bottom, and Y on this surface. This is R and Y, and blue blue on top, and Y and blue and red on this side. So we can have total of 8 cubes that have 3 different colors painted on them. Okay, what is the maximum possible number of smaller pieces that have red and blue colors painted on them? So what we need to do is, we need to maximize red and blue colors. Okay, so now what we will do is, we have to maximize red and blue. So let us minimize the other color. Okay, so if you have to maximize red and blue, we will try to minimize the other color, that is green. So now see the faces. The faces look like 6 into 5. One of the faces looks like 5 into 4, and the third face looks like 6 into 4. So we will try to maximize red and blue. So we will do minimum to green. Okay, so what we will do is, we will have only one face that is painted green. Okay, So this face is painted green, and then we will have the remaining faces painted that way. So this is 6 into 4, this is painted as green. Now we have to have red and blue, so we will put one of the faces here, another face here, and we will try to paint the remaining 3 faces. Like we will put, let's say we put red here and 3 blue, right? We can put any of these to maximize the count. Okay, so how do we maximize this count? Let's make the count here, how much we will get. Okay, now we have to have red and blue colors painted. So this is 6 into 4, so let's say this length is 6. Okay, this is 4, so this dimension is going to be 5, right? So we will have 5 cubes here because they have red and blue painted. So 5 here. Okay, they have red and blue painted. Then we will have 5 here, red and blue painted. 5 on the bottom also, so we will have red and blue painted. Now these are 6, we have already counted these we have already counted these pieces, right? So we will basically have red and blue, we have counted 20, and here we have 6 pieces, so we will have 1 2 3 4 that will have red and blue. Okay, and on the bottom also we will get 4 pieces that will have red and blue. So we have counted these 5, red and blue, 5 and 5 here and 5 here, so 20. These 4 will have red and blue, and on the bottom also we will have red and blue because bottom face is blue and this face is red. And then probably along this side also, this is a tough, now these are visualization problems, are really tough ones, so we will have to think of so we'll have to make, like this is green, this is blue, this is red, this is blue, and the opposite face is red. Okay, so red and blue ये वाले हो जाएंगे, red and blue ये वाले हो जाएंगे. This is not red and blue, this is basically blue and green. Okay, so we will not count this. So we will basically count these 4 because red and blue. So 20 तो ये हो गए 4 edges because they are red and blue, and then this 4 more here, and similarly 4 more downwards also. Okay, so this would be like, see there are 4 edges, right? We will exclude these 4 edges because they cannot have red and blue. This is including, so we will exclude these faces because this does not include red and blue. So remaining 8 faces, if we see 5 here, 5 here, 5 here, 5 here, so we got 20. Then we have 6 cubes along this face, we have counted the corner ones, so 4 here. Similarly 4 will be in the bottom because the bottom face is blue and the opposite face is no, opposite is also blue, so we cannot have there. So red we can have 20, and have the third color here. So these 4 we are sure because this is blue and red, 20 is there. Now this is blue and blue, so we will not count this. Similarly we will have these 3 we will count. Okay, because this is blue and this is red, and there are four pieces. So top and bottom are count, so 2 more here and 2 more here. Okay, so we are getting 24 thus far, and I guess one of these bottom is blue. Okay, and this is also blue, this is also blue. So we are getting 24. I don't know why it is coming incorrect. Sorry, my bad, I made a blunder here. We have to make minimum as green, so this is 5 into 4. Okay, so now we got it, it cannot be this. So 5 into 4 is this, so this dimension is 6. Okay, so we will have 6 6 6 6, that is 24. Okay, now this is 24 that have red and blue, and then we will have this dimension is 5 into 4, so this one of the dimensions will be 5. So out of the 5 we have already determined, remove the 2. Okay, so let's say this dimension is 4, this dimension is 6, and this dimension is 5. So we have determined 4 lines like 6 6 6 6, so 24 here. Then this is blue and this is blue, so we cannot have blue. Now this is 5, we have already counted these two, so we will count 3 this side and 3 that side also. So we can have maximum 30 red and blue colors. Okay, next is the maximum possible number of smaller pieces that have only red color on them. Okay, so maximum only red. So what we will do in this case is, again this is a visualization based problem. Okay, and only red color we have to make, so we will try to make all others minimum. So one of them we will give green, and one we will give to blue. Okay, so one is 5 into 4, right, and this is 5 into 6 into 4. So this we will give green, or this we will give as blue. Now if you see this this surface, like these are like this length is 5 into 4 and 6 into 4. So this length is 4, this is 6, and this is 5. Okay, so now we have to make only red color on them. Okay, so we have to make only red. So what we will do in this case is, we will basically take like these, take out these 4, because they will have, let's say this is green, this is blue. Okay, so these 4 will have green also, and remaining all are red ones. Okay, so all are red ones. Now we will take out these 5 and these so the remaining faces, this size is 5 into 6, the bottom is also 5 into 6, the opposite face is 5 into 4, and this face is 4 into 6. So we will remove these 4 cubes, right, and then we will have and we shall remove these 4, so we will be left with 20 here. Okay, this 30 we will remove these 5 and 5 10, so 20 here. Okay, and then we can have this is 5 into 4 20, and like in this part we have 20, we have 20 remaining, because 5 are these and 5 are these. We have 20 and we have removed these 4, so 16 here, and so we will get so this, I guess we can get up to maximum 56. Okay, only red, we have to get only red colors. Okay, so we will remove this green part. Okay, and this blue part so we have to get only red, right? So the thing is, only green will be removed. 20 is only green, 30 is only blue, so 120 cubes are there, Okay, how many are invisible? Invisible are 4 into 3 into 2, that is 24 invisible. Okay, so this is total. This is 20 is green, right? 24 is blue, 24 is invisible. So we have got 100 minus 48, 72. 72 now 4 are hidden here because they contain green also. Then 4 will be here 8, and similarly 5 on this and 5 on this. Okay, so we could get, I guess, 56 that will have only red color on them. Okay, so try this like and see that, let me know that if you get 56 as the answer. So that is the highest that we could get. Okay, what is the maximum possible number of smaller pieces that have neither blue nor red color on any of the faces? So we have to have maximum possible colors that have neither blue nor red color. Okay, so we will give minimum number to red, or like we have to give maximum without red or green ones. Okay, so blue or red हमें नहीं करना है, so we will try to give green to the maximum number. So blue or red नहीं देना है, so let's put blue at this side and red as this side. Now they have 20, this is 20 and this is 24, and 4 are common. Okay, so if you let's just make so we have to have maximum neither blue nor red. So this is blue, this is red. Okay, so we see we have, this is 5 into 4 20, and this is 24. So 20 and 24 and 4 common. So that means 40 have blue or red. Okay, so remaining 80, like total 120 cubes are there, 40 have blue or red, so 80 will not have any of these blue nor red on them. Okay, if it says if 38 pieces have only one face painted which is blue, how many pieces have only red and green colors on their surface? So answer this question in the comments of this video, that how many pieces will have only red and green colors painted on them. So try to solve this question on your own and do let me know in the comments of this video the answer to this particular question. In case you are preparing for CAT and OMETs, okay, we have launched this test series which will cover all MBA entrance examinations, and you are already aware of the great content that we provide for all MBA entrance exams. So you can get a discounted price for this series until the end of this month. You can use the code HOT and get 20% off till end of this month. So there has been a very high demand for our CAT course due to this series, and as a result we have decided to launch a crash course, but that will be launched somewhere around September. Okay, so right now we have a full-time batch running. So once that batch gets over, so probably then we can start this batch. So it will be around September, and that will cover the syllabus at a fast pace. That will be a good revision batch as well. So in case your concepts are clear, the basics are clear, you want to practice advanced questions and practice in the last couple of months, you can join this batch. So please do subscribe to our channel and our Instagram page and Telegram page to get updates on the same, because these are the sources through which we give updates on our upcoming batches. So in case you are interested in this batch, please do subscribe to them so that you don't miss out any of the notifications. Okay, so apart from those questions which I asked you to comment, answer these two questions also. So there is one on binary logic and another question on cubes. So answer these in the comments of this video, and in order to get the PDF of this class, please join our Telegram group. So this was day 29 of hot summer, and I'm sure you must have enjoyed this series throughout. One more video to go, please do watch that as well, and this complete 30 video series will boost your preparation like anything else. And I'm pretty sure if you use the techniques that we taught in these videos, that will benefit you a lot in CAT and other MBA entrance examinations. So thanks for watching this video. Have a great day. Goodbye.